In this video, we're going to be discussing circular motion. Arc length, and again, we just discussed arc length, can be used to analyze circular motion. Suppose an object moves along a circular path, and that would be kind of like an amusement park ride or something, where something is spinning in a circular path. The rate, let me erase that. The rate at which the object moves along the path is called its linear speed. And there is a formula for linear speed, and it is this. Linear speed is equal to, and I put V because V stands for velocity, and velocity is a linear speed. Linear speed is equal to S divided by T, to where S is an arc length, and T is a time. So you've got a distance, an arc length, a distant measure. So arc length is measured in feet, inches, miles, and so on and so forth. Time is measured in hours or minutes. So the way I remember this, linear speed, you have like miles per hour, to where S could be measured in miles, T could be measured in hours. So linear speed is just like if your car was traveling in a circular orientation, you have this miles per hour. However, you also have this other rate. The rate at which the central angle is changing along the path is called its angular speed. And we use this symbol, which is the Greek letter omega, to represent angular velocity. And again, think about what we're measuring. We're measuring the rate at which the angle is changing. So what you're going to have the angle divided by time, to where this theta is your central angle. And again, T stands for, of course, time. So you might have the central angle might be measured in degrees or radians, and then the time would be in minutes, seconds, so on. So you'd have like degrees per minute or radians per second or something. Okay, some examples. Recall, each rotation or revolution has a circumference of 2 pi, or 2 pi r, and a central angle of 2 pi radians. So remember that as we go through these. So number one says a bicycle tire with a radius of 14 rotates at a rate of 125 revolutions per minute. And if you'll notice RPMs, we see those on the dash of our car. RPM stands for revolutions per minute. So we have our radius. The tire has a radius of 14 inches, and the angular velocity. They give us 125 revolutions per minute. Now, I said angles are measured in degrees and radians, but angles could also be measured in revolutions. So our angular velocity is 125 revolutions per 1 minute. Okay, first off, let's find the arc length. So our arc length here, one revolution, a reminder of what they just said, each rotation or revolution has a circumference of 2 pi r. So one rotation would be 2 times pi times 14. That would be one revolution. However, this is going to go around 125 times in a minute. So therefore, what we're going to do is we're going to multiply that by 125 rotations. So this is one revolution times 125 revolutions, multiply all that together, and you get 3,500 pi inches. And that is in inches because the radius was in inches. So therefore, in this amount of time, in this 1 minute, we're rotating 3,500 pi inches. So therefore, the linear speed, if you don't remember the formula for linear speed, it's right here. Velocity is equal to arc length over time. So therefore, our arc length was right here, 3,500 pi inches per, and our time is 1 minute. So again, this is rotating. That's all we're asking is how far is this thing rotating each minute? If it rotated 105 revolutions. So that's it. That would be your linear velocity. The second part says find the angular speed of the tire in radians per minute. And really all we're having to do here is I know that my angle was equal to 125 revolutions. Well, I don't want it in revolutions. I want it in how many radians would that be? So 125 revolutions, I know that I can multiply that 125. A single revolution is 2 pi radians. So therefore 125 times 2 pi, that would be 250 pi radians. So what I just did is I took my 125 revolutions or 125 spins and I changed it to radian measures. So 250 pi radians is the same thing as 125 spins. So now my angular velocity is equal to my central angle divided by time. So my central angle, instead of 125 revolutions, is now 250 pi radians per, and then that was in, let's see, it was in RPM, so it was already in per minute. So my time is 1 minute. So again, all I did was I changed 125 revolutions per minute to simply 250 radians per minute, because 125 revolutions and 250 radians is the same thing. Used for questions 3 and 4, a CD with a diameter of 120, so that means our radius would be 60 in case we need that, and that's in millimeters. Rotates at 45 RPMs. So first I'll find the linear speed in millimeters per minute. So linear speed is equal to arc length divided by time. So we know that in that 1 minute, it rotates 45 revolutions. So let's go ahead and change that. We need that in distance. We need that in arc length instead. So let's find our arc length to begin with. 45 revolutions, and I know that my diameter is 120, so my radius is 60. So one revolution is, again, pi times diameter or 2 times pi times radius, which is the formula they gave us over to the side. So I'm going to use my pi times diameter. So one revolution would be 120 pi. However, this goes around in 1 minute, it goes around 45 times. So in that single minute, we rotated a total distance of 120 pi times 45, which is 5,400 pi, and that again was in millimeters. And that's the distance that we rotated in that 1 minute. So therefore our velocity would be that distance, 5,400 pi millimeters per, and that's how far we rotated in 1 minute. So therefore our velocity is that distance per minute, because that's how far we're traveling each minute. Number 4, find the angular speed. So therefore, again, our angular speed is equal to the central angle divided by time. So we already know that we're traveling at a rate of 45 RPMs. That is 45 revolutions per minute. So all we're really needing to do is change that 45 revolutions. Let's talk about our angle. Let's change 45 revolutions to radian measures. The way that we're going to do that is 1 revolution is equal to 2 pi radians. So therefore 45 revolutions, we're simply going to do 45 times 2 pi, and that's going to be 90 pi radians. So that's the distance that we're traveling, and that's the exact same thing as 45 revolutions. So therefore our angular velocity is 90 pi radians per minute, and that's in radians per minute. So really, again, I want to share with you that this 45 revolutions per minute is an angular velocity. However, the angle, they're given in revolutions instead of radians. That's the only difference. Number 5, a 16-inch diameter tire on a car is making 500 revolutions per minute. Again, that's kind of like your angular speed. You're spinning 500 revolutions each minute. It spins 500 times every minute. It has a 16-inch diameter, so I'm going to put that the radius is 8 inches. Find the linear speed of the tire in miles per hour. So let's first off start by finding the linear speed in inches per minute, since that's what we're given is inches in minute. So let's take our 8 inches, and if it spins 500 revolutions, well, we know that 1 revolution, let's talk about, again, our arc length. I know that to find 1 revolution or 1 spin, the distance around this, we're going to do 2 times pi times the radius. That is 1 revolution. However, this thing is going to spin 500 times in that 1 minute. So this is the distance that it's going to go in that 1 minute. And that's going to be 8,000 pi. And that was in, let's see, I always leave it off. That's in inches. Yeah, it was right there. So that's the arc length. So therefore our linear velocity, let me write it down here. Our linear velocity is we're traveling 8,000 pi inches per that 1 minute. However, we want this in miles per hour. Now let's go back and let's actually talk some physics here. We're going to do some conversion factors. How do I change from inches per minute to miles per hour? Okay, it's like this. I know that there is 12 inches in 1 foot. And if you'll go back to the way that we changed from radians to degrees by using conversion factors, we're kind of doing the same thing here. I know that there are 12 inches in 1 foot. So think about what you're multiplying by. 1 foot over 12 inches. That's the same thing. I'm multiplying by 1. Okay, and this is very legal as long as the top and bottom here are the exact same measurement. 1 foot, 12 inches, same thing. So why are we doing this? Notice I put inches on bottom, and over here inches are on top. Those are actually going to cancel each other out. And now if I were to stop right now, my answer, when I multiply the tops and bottoms and divided, my answer would be in feet per minute. However, I want miles per hour, so let's continue on multiplying by conversion factors. So next up, let's stay with our feet up here, and let's change that into miles somehow. I know that there are 5,280 feet in 1 mile. Feet on top cancels with feet on bottom. My answer is now in miles per minute. I want it in miles per hour, so we got one more step. My top is correct. I have it in miles. On bottom, my minutes. I need that as hours. So the way I can do that is I know that there are 60 minutes in 1 hour. Minutes on top cancels with minutes on bottom. You have to make sure you place them to where they will cancel. So now my answer, notice your units on top are in miles. Your unit on bottom is hours. So therefore, once you multiply all these tops out, you multiply all these bottoms, your answer is now going to be in miles per hour. So on top, what you're going to do is multiply 8,000 pi times 60. On bottom, you're going to multiply 12 times 5,280. You're going to divide those two answers out, and you're going to be done. Once you do all that work, you're going to get 23.8. Again, the top is in miles. The bottom is in hours. Make sure, again, you multiply this times this, multiply this times this, divide those two answers because you have the division symbol, and again, you get 23.8 miles per hour, which most of the time we write as 23.8 mph. Either one of those answers are correct. Okay, number 6. It says a circular saw blade has a diameter of 9 inches, rotates at 2,800 RPMs. Find the angular speed of the blade. Now, since we're looking for an angular speed, let me share with you that the actual radius does not matter. So this is extra information because they give you the angular speed. It is 2,800 revolutions per minute. That is an angular speed. The only thing they're asking you to do is change that to radians per second. And the way that we're going to do that on this problem, you could have actually done this on a couple of problems ago, is we're going to simply use conversion factors. Now watch. Instead of revolutions per minute, I want radians per second. So let's start with revolutions. I know that one revolution, which is again one spin, is equal to a total of, we want radians, so one spin is 2 pi radians. 360 degrees is a spin, 2 pi radians is a spin. That is one revolution, one revolution. So what I'm going to do is I'm now going to cancel my revolutions. And on top you have radians, which is what we need. But we want radians per second. So I've got to somehow change minutes to seconds. Here's all you do. I know that, okay, minutes are on bottom, so I'm going to put minutes on top. I know that 1 minute is the same thing as 60 seconds. Minutes cancel with minutes, and I now have my seconds on bottom like I need. So I now have my answer in radians per second. How do I actually get the answer? On top, you're going to multiply 2,800 by 2 pi. And you can actually write it down if you want to. That'd be 5600 pi over, on bottom, you're going to multiply 1 times 60, which is just 60. Once you do that, divide those two answers, and you're going to get about 293.2, and again, that is in radians per second. So we can put radians per second. That's your final answer. Number 7, a windmill has blades that are 14 feet long. So those blades being 14 feet long, that would be the radius of your windmill. The windmill is rotating at 5 revolutions per second, so that would be your angular velocity. The angle is changing at 5 revolutions every 1 second. Find the linear speed of the tips of the blades in miles per hour. Okay, our first step is we're going to find our arc length. So we know that if we're traveling at 5 revolutions every second, okay, our arc length there, 5 revolutions each second. We know that since 1 revolution, okay, we can find 1 revolution by doing, that's the circumference, is 2 times pi times the radius, which in this case is 14. That would be 1 circumference. I'm going to put a C below it because that's the circumference. However, in that 1 second, we're spinning 5 times. So we're going to multiply by 5, and that's going to give us our total arc length. So multiplying that, that's going to be 140 pi, and that is in feet. So therefore, that is our arc length. That's how far we're traveling in that 1 second. So therefore, our angular velocity is equal to 140 pi feet per second, because again, angular velocity is arc length divided by time. Our time is 1 second, our arc length 140 pi feet, so therefore we've got it. However, we want our answer in miles per hour. So therefore, we're now just using conversion factors. We've got our answer in feet per second. So now let's change our feet to miles using the same conversion we did a while ago. I know 5,280 feet is equal to 1 mile. Notice how I put feet on bottom so that feet cancels with feet. Now my answer is in miles per second. So let's change. I want miles per hour. I know that there are 60 seconds in 1 minute. And you could actually skip a step on this one. Seconds cancels with seconds. My answer is now in miles per minute. I know that there are 60 minutes in 1 hour. Minutes cancels with minutes, and my answer is now in miles per hour. So what we are now going to do is multiply on top with our calculator, 140 pi times 60 times 60. Get an answer. We're going to multiply all the bottoms, which is pretty much 1 times 5280, which is just 5280. So multiply all the tops, divide it by 5280, and you're going to get 299.9, and that is in, there are miles left on top, hours left on bottom, so we could say 299.9 mph is the abbreviation. Now that we've done it the hard way, there is another way of using this, or another way of working this, using angular speed to find linear speed. Okay, now let's go through these steps and just remind you, the linear speed v can be used to can also be found as follows. We know that speed, linear speed, is arc length over time. And let me remind you of a formula that we did, I believe it was last lesson. Arc length is equal to r times theta, radius times angle, or times central angle. So let's take s and replace it with r theta. Now let's write that as r times theta over t, which is the exact same thing. All I did was separated it. And theta over t should look somewhat familiar. That's arc length, or excuse me, that's angular speed. That's angular velocity. So we can replace that with r times angular speed. And we now have a new formula. Therefore, you can use angular speed to find linear speed. Linear speed is equal to r times angular speed. You simply have to take your angular velocity, multiply it by the radius, and you have your linear velocity. I do need to remind you, however, that when you're dealing with these, remember when we did r times theta, theta must be in radians. So therefore, make sure that you're in radian measures before you use this formula. Number 8, a ceiling fan with a 25-inch blade rotates at 40 RPMs. So what we have here is we have an angular velocity of 40 revolutions per minute. We also have a blade, a ceiling fan blade of 25 inches. And the reason that's a radius, the way that a ceiling fan is made, like this right here, if the blade, there we go. If the blade is 25 inches, that's the distance from here out to here. That would be the radius of the entire ceiling fan. So that's why we call that the radius. So the radius is 25 inches. We're asked to find the linear speed, so we're looking for the V. We're asked to find the linear speed of the tips of the blades in feet per second. So the linear speed is equal to, and again, we can use our new formula, the radius times the angular velocity. Now remember, in order to use this formula, our angular velocity, let me move this over, we can just do it right here. Our angular velocity must be in radians per minute. We can't use revolutions, so let's go ahead and change that. I know that 1 revolution is equal to 2 pi radians because 1 spin is 2 pi radians, so therefore revolutions cancel, and that's going to be 80 pi radians per minute. Now I can use it. Again, my radius was 25 inches. So now my linear velocity is just this. We're going to do 25 inches times our angular velocity, which is 80 pi radians per minute. Now, here's the only problem. This is going to give me my answer. Now, this is what's weird about this formula. This radian measure just kind of disappears. Our answer is now in inches per minute. We want it to be in feet per second. So once I multiply this out, 25 times 80, that's going to give you 2,000 pi. And again, that's in inches per minute. That is your linear velocity now. However, now all we've got to do is change it to feet per second and we're finished. So I know that there are 12 inches in a foot. So now mark out the inches. I'm in feet per minute. I know that, let's see, we want it in feet per second. I know that there is, that 1 minute is equal to 60 seconds, and the minutes cancel. Now my answer is in feet per seconds. Multiply everything on top, which is pretty much just this. Multiply everything on bottom, which is 12 times 60. So do the 2,000 pi on top, 720 on bottom, divide the two answers, and you get 8.7. And again, that is in feet per second. So you could just do feet per second there. There we go. Number 9. Ryan is riding a bicycle whose wheels are 28 inch in diameter. So let's go ahead and put that our radius, because our formula is velocity. Linear velocity is radius times angular velocity. So the radius is 14 inches. If the wheel rotates at 130 RPMs, again, this is an angular velocity. However, in order to be able to use it, 130 revolutions per minute, we need to change that to radians. So therefore, I know that 1 revolution is equal to 2 pi radians, so that revolutions will cancel, and that gives you 260 pi radians per minute. That is your angular velocity. Now to find linear velocity, it's simply this. Linear velocity is the radius of whatever is spinning times the angular velocity. So your linear velocity will equal the radius, which is 14, and that's in inches. Let me go ahead and put that, 14 inches times 260 pi, and you don't have to put the radian measurement, you don't have to put RAD there, because again, that radian is kind of absorbed by the formula. So when I multiply this out, my answer is going to be in inches per minute. So if you would like to, instead of multiplying it out now, what you can go ahead and do, we want our answer in miles per hour. So let's go ahead and change it before we even multiply it. On top, my answer is in inches. I need it in miles. So I know that there is 12 inches in 1 foot. And when I do that, my inches will cancel. I know that there are 5,280 feet in 1 mile. And I did that so that my feet will cancel. So my top is exactly what I wanted in. It's in miles. However, my bottom, I need it in hours. Right now I have it in minutes. I have 1 minute on bottom, so cancel it. I know that there are 60 minutes in 1 hour. So the minutes do cancel. So what you're going to do on top, let me change markers here. You're going to multiply 14 times 260 pi times 60. You're going to get an answer. On bottom, you're going to multiply 12 times 5,280. You're going to divide those two answers, and you're going to get 10.8. And again, that is in miles per hour, so you can just put MPH.